Hey everyone, welcome to homework mid-unit day number 2. Today's homework is a review of solving linear systems of equations because we're going to be doing solving inequalities. And when we do solving inequalities, you need to be able to graph just a regular line super well. So I'm going to go through, I put the steps here at the top of your paper so you have them as well. But when we are graphing, there's two ways that you can do it. The way that you'll get the most points, and the best way to do that, is to put it into slope-intercept form, which remember is y equals mx plus b. All you're doing really then is solving for y for both equations so that then you can graph them using the slope m and the y-intercept b. You can also find the x and y intercepts by substituting in 0 for x or 0 for y and seeing what you get with the other point. And once you've put in x or y as 0, you'll find the other x or y, right, which will allow you to plot a point. And I'll show you an example of what I mean down below. Then you graph each equation, look for the point of intersection, and make sure that it works. So an example, 2x. Well, what is here is 2x plus 0. So here the y-intercept is 0. So I'm going to go ahead and graph that. It's already in slope-intercept form. And so all I'm going to do is use this slope. That's 2 over 1. So I'm going to go up 2 over 1, up 2 over 1, up 2 over 1. And I'm confirming that this does have a positive slope, so it should be going in that direction, right? And so then I can form my line here. Not the best line, but you get the idea. All right. Then I need to graph my other line. And so this is going to be a negative 1 over 1 slope and a y-intercept of 3. So now I'm going up 1, 2, 3, and I'm going down 1 over 1. So down 1 over 1, I already found my point of intersection. Going this way. Okay, and I easily found point of intersection here is 2 comma 1. Or sorry, 1 comma 2. Careful there. 1 comma 2. Over 1 up 2. And then I'm going to verify. Well, if I plug in 1 for x in the first equation and 2 for y, I get 2 equals 2 times 1. That works. And then in the second equation, if I do 2 equals negative 1 plus 3, that does also in fact equal 2, so I know that it works. Let's look at the next example. So in the next example, this is not in slope-intercept form, so I need to put it into slope-intercept form. So I'm going to rewrite this down here. Y minus 2x equals negative 4. Well, now I want y to be by itself because I want it to be, again, y equals mx plus b form. And so I'm going to add 2x to both sides. This will give me y equals 2x minus 4. Now I could also write that as negative 4 plus 2x, but I want to put it in this form so I can easily see that my slope is 2 and my y-intercept is negative 4. So let's start 1, 2, 3, 4. I'm going to put my point here, and then my slope is 2, positive 2, so it's going up 2, that's the same as 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, 2 over 1, and so forth and so on. And then I can go ahead and draw my line. Okay, so that's going to be, let's see, actually, that's as good as it's going to get. Okay. The other equation is this one right here, which is already in a slope-intercept form. My m, the invisible number coefficient of x, is 1 over 1, so that's my slope, and b is negative 2. That's my y-intercept. So I'm going to go down to negative 2, and it is a negative slope, and so, actually I didn't point, oh no, it's a positive slope. It's a positive slope of 1 over 1, so I'm going up 1 over 1, up 1 over 1. See that point of intersection there, up 1 over 1. Okay. And so then I can connect the dots here, and this will be my solution there. That is 2 comma 0. Again, I'm going to verify. 0 minus 2 times 2 equals negative 4. I see that's negative 4 equals negative 4. That's true. And then the bottom one, 2 equals 0 minus Did I do that right? Oh, nope, I did it wrong. Y equals 0. So 0 equals 2 minus 2, which is 0 equals 0. So that is also true and works out. All right. Number 2. Ooh, that looks kind of funny on this computer. Let me make sure that I put the symbols in correctly. Hopefully it looks okay on your paper. I didn't notice a problem on it in yours. Let me double check. Let's make sure. Oh yeah, it's just mine looks weird. So this should be y equals negative x plus 5 and y equals x plus 1. All right, so these are already in slope-intercept form. We're going to start with my m here is negative 1 over 1, and my b is 5. And then here my m equals 1 over 1, positive 1 over 1, and my b equals 1. So let's graph the first equation. We're going to go up 5. That's our starting point. That's our y-intercept. And it's a negative slope, so it's going down this way. So down 1 over 1, down 1 over 1. And I am noticing that my graph is going 1 by 1, so this is perfect. Okay? Now my other equation, it's not the most perfect line, there we go, is positive 1 here, and then we're going positive 1 over 1, so we're going to go up this way. And we very quickly can see the point of intersection is right here, which is 2, 3. So then your next job is to check those answers. So 3 equals negative 2 plus 5. Yes, that works. And then 3 equals 2 plus 1. Yes, that works. Okay? Number 2 says 2x minus y equals 2 and x equals 3. All right, so my first equation is not in slope-intercept form, and I want it to be. So we're going to solve for y. So let's do that over here. 2x minus y equals 2. Write each step down so you don't skip any steps. That's very important. We'll get negative y equals negative 2x plus 2. Remember, there's an invisible positive in front of that 2. And then I'm going to multiply by negative 1 because I need to get that negative out from in front of the y. So we get y equals 2x minus 2. Now I have a y-intercept and a positive slope of 2 over 1, and so I can graph that very nicely. Okay, oops, oh, I pressed the eraser. Not very nicely, there we go, okay. All right, now x equals 3. This one is interesting because we don't have a y equals here, right? So I can't solve for that. But this also means that wherever x is always going to equal 3, no matter what y equals. So on the x-axis, 3 is here. So no matter what y equals, x is going to equal 3, which means this is going to form a vertical line. And so therefore, you can see that it passes right through here. Okay? So there is no, right, there's no slope to worry about here or anything like that because x always equals 3. And if x always equals 3, it's going to form a vertical line. If we were to have y equals 3, which we don't, but if we did, then that would mean that anywhere we go on the x-axis, y will equal 3. And that would create a horizontal line. Okay? All right, so again, we found... Whoa, what just happened? Come back. All right, so we found our answer there. And so now we can substitute in 3, 4, correct? 3, 4, and see if that works, okay? So in our equation, 2 times 3 minus 4 equals 2. 6 minus 4 equals 2, yes. And then no matter what x equals 3, x does equal 3, 3 equals 3, so that works. Okay. Number 3 is 2x plus y equals 2, and x minus y equals 4. Now, neither of these are in slope-intercept form, so let's convert them. So 2x plus y equals 2, and x minus y equals 4. All right, so I want to solve for y, so I'm going to subtract 2x on both sides. We'll get y equals negative 2x plus 2. And then here, I'm going to get minus x on both sides, and we'll get negative y equals negative x plus 4. Multiply the whole thing by negative 1, and we get y equals x minus 4. Okay? Now I can graph them. I have a negative slope. This is going down, y-intercept of 2. going down 2 over 1, down 2 over 1, down 2 over 1, up 2, back 1, okay, and then we can go ahead and draw our line through there. All right, x minus 4 is negative 4 here. This is a slope of 1 over 1, so up 1 over 1, up 1 over 1. We see that point right there already where it's intersecting is going to be 2 comma negative 2. And then, of course, let's check our answer. So we get 2 times 2 minus 2 equals 2. That's 4 minus 2 equals 2. That works. And then 2 minus a negative 2 is the same as 2 plus 2, and that does, in fact, equal 4. So when we plug these into these two equations, it works for both of them. All right, let's look at the next page. All right, so the next page has you doing the same thing. Now, luckily, your first one and your second one are already in slope-intercept form. So I'm not going to do those with you. You can do those on your own, okay? That practice is important, though, so make sure you do them carefully. This one, I want to solve for y, so I'm going to subtract x from both sides. I'll get negative y equals negative x plus 2. We're going to multiply the whole thing by negative 1 to get y equals x minus 2. And then same thing here, let's subtract x from both sides. We'll get y equals negative x minus 6. So now you have a y-intercept over here of 2 and a slope of, negative 2 and a slope of 1 over 1. All right, and so we're going to do our y-intercept here, and then up 1 over 1, up 1 over 1. It's a positive slope. Okay. And so, shoo, there we go. And this one's negative 6, and then it's a negative slope going this way of 1 over 1 as well, like this. Now we have our point of intersection, negative 2 comma negative 4. And if you plug that in, you should check your answers to make sure it works. You will get a negative 2 minus negative 4 equals 2. That is negative 2 plus 4 equals equals positive 2 equals 2. That works. And then our second equation, negative 2 plus a negative 4 gives us negative 6. That does work out. Okay? So we checked our answers and that worked out. All right. This one over here, first equation, we're going to subtract x from both sides. We'll get y equals negative x minus 2. Again, we're reordering these because of our commutative property. This would be negative 2 minus x. That sign stays with the value that it is in front of, okay? So that negative needs to move with that when we use the commutative property. This is the same as negative 2 plus negative x. And so if that helps you to think of it that way, you can. Now here I want to solve for y again, so I'm going to do minus 7x on both sides. We get negative 4y equals negative 7x plus 8. And now I'm going to divide both sides by negative 4. And remember, I have to divide everything by that. So this will cancel out, leave me with y equals, because 4 divided by 4 is 1, equals 7 over 4, negative divided by negative. So this is going to be positive, 7 over 4x, and then a positive divided by a negative is going to be negative 2. What is really important here is that you leave this as a fraction. If you convert it to a decimal, you're going to have a hard time graphing it. So when you're graphing, leave that as a fraction because that top number tells you how far up and down, the rise, and the bottom number tells you how far left and right, that's our run, okay? So looking at this now, we have both of them, interestingly, have a y-intercept of negative 2. So that is going to be our point of intersection, but let me just prove it to you. So here we have negative 1 over 1 as our slope, and so I'm going to be going down, and let's go ahead and graph some points there. And then over here, negative 2, and we're going up 7. 1, 2, 3, 4, 5, 6, 7, and over 1, 2, 3, 4. All right, and so if I just connect those 2 points, this is the point of intersection there. So that is 0 comma negative 2. And if you plug that in, then you will see that you get the correct answer, okay? So you can check your work, make sure it works out, but what I want you to really focus on here is practicing putting these into slope-intercept form so that you can graph them. All right, down below, you're doing the same thing, okay? You're going ahead and use the space below to show your work. Put them into slope-intercept form. Write it out. A lot of you are doing this in your head, and then that's where you're making your sign mistakes. So if you do this and you write it out, you're less likely to make a mistake with your sign. All right, so x minus y equals 1. Subtract x from both sides. We get negative y equals negative x plus 1. Multiply the whole thing by a negative. We get y equals x minus 1. Okay, so these are now the two equations that you're using to graph. I'm going to give you that much, and then you can do the graphing. Let's try this one. This one's already in slope-intercept form, so I can easily graph this one first. Let's look at the one above. 4x minus 2y equals negative 8. We want to get y by itself, so let's subtract 4x from both sides. Negative 2y equals negative 4x minus 8. I'm going to divide both sides by negative 2. I'm already dividing by negative, so this will cancel out. And we get y equals negative 4 divided by negative 2 is positive 2x. Negative 8 divided by 2 is positive 4. All right, now look at these equations. What do we see about them? What should that mean for how many solutions there are? All right, this next one is already in slope-intercept form for both of them, so I'm going to let you graph that one on your own. This is our slope. Remember, that's a slope of negative 3 over 1. This is your slope here, 2 over 1, and then these are your y-intercepts. Okay, that tells you where on this line you're graphing them. Let's look down below. Okay, number 4 is also already in slope-intercept form. The thing about this one is that you have fractions, right? And again, they left them as fractions because this gives you a slope of negative 3 over 2. It tells you how far up and down you're going and side to side you're going. All right? Again, that's something you can do. It's already in slope-intercept form. Let's try number 5, though. So we have 4x minus 6y equals 12. Again, solving for y, let's go ahead and subtract 4x from both sides. We'll get negative 6y equals negative 4x plus 12. Divide both sides by negative 6. Okay. Then this cancels out. We get y equals, this is a positive now. 4/6 is the same as 2/3 x. Again, leaving it as a fraction because it'll help me to graph. And then positive divided by negative gives me negative. Okay, so now I have one of my equations. Let's look at the other one. The other one, I'm going to use a space here. 2x plus 2y equals 6. Solving for y, let's subtract 2x from both sides. We get 2y equals negative 2x plus 6. Divide both sides by 2. We get y equals negative x. So negative 1 over 1 plus 3. All right, so now you have two graphs that you can graph here, okay? Because we have our slope-intercept form, we can go ahead and easily figure out what that needs to look like. The last one, you can go ahead and put this into slope-intercept form. Subtract x from both sides. We get negative y equals negative x minus 4. Multiply the whole thing by a negative. We get y equals x plus 4. Okay, those negatives all end up getting canceled out, which is really nice. All right, so that you can now graph, right? This y equals 3 is what I was talking about earlier. This means that wherever x is, no matter which part of x is, it's going to be y equals 3. So we can just plot a bunch of y equals 3 points and connect them, because no matter where we go, y is going to equal 3, so this is going to create a horizontal line. And then we found this down here, our y-intercept is 4. Our slope is 1 over 1, positive, so it's going to go down like this. Oh, that was not a very good line. Whew. Drawing on the iPad these lines is quite difficult, y'all. All right, and so then we can see this is our point of intersection there. Okay, remember you want to list your answer as an ordered pair. All right, that's it for your homework tonight. Your code word for today, I loved your interesting spellings of Pachaco last week. So your code word for today is keroppi. Keroppi. I want to see how y'all spell that, and if you look it up and figure out who that is and tell me, then that'll be super fun and extra credit. So Keroppi. All right, thank you for listening. Do your homework, and I'll see you tomorrow.